API endpoints returned 500 errors with unknown field legacy status, and TypeScript compiled without a peep. The CI pipeline ran the build before the migration, baking a stale Prisma client into the deployment artifact. Let's break down the new T3 stack in 2026, complete updated guide, how it works, and the exact mistake behind that failure. The T3 stack is a curated set of tools that together provide end-to-end type safety from database to browser. Each tool solves a specific problem. Next.js for rendering, tRPC for type-safe APIs, Prisma for type-safe database access, Tailwind for styling, and TypeScript as the connective tissue. The type chain starts with your Prisma schema. Prisma generates a TypeScript client where every query is typed. tRPC infers its return types from the Prisma query output. On the client, React components get typed props from tRPC hooks. One change at the top propagates to the bottom. Here's a typical Prisma schema. The user and post models define your database tables. Prisma generates TypeScript types from this schema, so every query is type-checked against these models. tRPC v11 gives you end-to-end type inference from database to browser with zero code generation. You define a procedure on the server, and the client gets auto-completion and compile-time type checking. This is a tRPC router for posts. It defines 3 procedures: list public with cursor pagination, create protected, requires auth, and get by id, protected, with authorization check. The input is validated with Zod, and the return types are inferred from the Prisma queries. Prisma generates a type-safe client from your schema. In serverless environments, you need connection pooling to avoid exhausting database connections. Prisma Accelerate provides that pooling and edge caching. This singleton pattern prevents creating multiple Prisma client instances during hot reloading in development. It also adds the Accelerate extension for connection pooling in production. Shadcn/UI is not a library. It's a collection of copy-paste components built on Radix UI primitives and styled with Tailwind. You own the source code, so you can customize anything without fighting abstraction layers. Here's a custom data table component built on Shadcn/UI primitives. It supports search, pagination, and custom cell rendering. Because you own the code, you can modify it to match your design system exactly. Organize your project by domain, not by technology layer. Each feature gets its own directory with its router, components, and types. This keeps related code together and reduces cognitive overhead as the codebase grows. This is the recommended project structure for a T3 stack application at scale. Notice how each feature has its own directory under app, and shared code lives in lib and components/UI/. Authentication in the T3 stack is handled by Next.js integrated with tRPC middleware. You define a protected procedure that checks the session and throws unauthorized if not authenticated. This keeps auth logic centralized. This middleware checks the session and adds the user to the context. Then protected procedure can be used in any resolver that requires authentication. The user object is fully typed from the session. Edge functions are stateless and short-lived, so they can't hold persistent database connections. Use Prisma's driver adapters for Neon or PlanetScale, and route queries through a centralized pooler like Prisma Accelerate. This example shows how to set up Prisma with the Neon adapter for edge runtimes. The pool manages connections server-side, and the adapter allows Prisma to use it without the binary engine. This is the same issue we highlighted at the start. Here's exactly why that happened. The CI pipeline ran next build before Prisma migrate deploy. The build used the old Prisma client that still had legacy status. The migration then dropped the column, but the deployed artifact had the stale client, causing runtime errors. Running next build before Prisma migrate deploy bakes a stale Prisma client that references a dropped column, causing runtime errors. The fix was to reorder the CI pipeline, run Prisma migrate deploy first, then Prisma generate, then next build. Also add Prisma validate before build to catch schema drift, and add Prisma generate as a post-install script to ensure the client always matches the schema. This is the exact mistake that caused the outage. Running next build before Prisma migrate deploy bakes a stale Prisma client into the artifact. Always run migrations and client generation before the build. If you chain Auth Middleware before input validation, an unauthenticated request with invalid input will fail with an auth error instead of a validation error. Always chain validation middleware first, then auth. Prisma doesn't automatically create indexes on foreign keys. Without an explicit edit index, queries filtering by authored will do full table scans, causing latency to spike from 2 ms to 500 ms at scale. In Prisma v5+, running Prisma migrate dev does not automatically regenerate the Prisma client. You must run Prisma generate separately. This is a common pitfall that leads to stale client types and silent runtime errors. Always add a CI step that runs Prisma generate after Prisma migrate deploy. The correct CI order is 1. Prisma migrate deploy, 2. Prisma generate, 3. Next build. Running build before migration bakes a stale client into the artifact. Add Prisma validate before build to catch schema drift. To detect a stale Prisma client in production, compare the migration timestamp with the generated client timestamp. You can add a health check endpoint that runs Prisma validate or checks that the client schema hash matches the latest migration. This prevents silent data corruption from schema drift. Here are common debugging steps for T3 Stack issues. If you get runtime type errors, regenerate the Prisma client. If a server component shows loading forever, check it's not accidentally marked use client. For stale data, invalidate the tRPC cache. For slow queries, run explain analyze. Let's run through some common interview questions. Explain the type chain in T3 Stack. Schema: Prisma right arrow Prisma client right arrow tRPC right arrow React, one change propagates everywhere. How does tRPC differ from REST? End-to-end type inference without codegen, best for TypeScript-only stacks. What is shadcn/UI versus MUI? Shadcn/UI gives you source code you own. MUI is a dependency with less customization. And a few frequently asked questions. Can I use T3 Stack without tRPC? Yes, but you lose end-to-end type inference. How do shadcn/UI updates work? Run npx shadcn/UI at latest diff to see changes, then manually merge. Which database works best? PostgreSQL with Neon or Supabase for edge compatibility. Let's recap the key takeaways. Type chain: schema right arrow Prisma right arrow tRPC right arrow React. Always run Prisma generate after migrations. Connection pooling mandatory for serverless. Domain-driven structure scales better. Ready to go deeper? Up next, how to fix Next.js 16 hydration errors once and for all, then Next.js 16 plus React 19 complete migration guide, then advanced error handling and logging in Next.js 16 applications, and building an AI SaaS from scratch with Next.js 16. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.